First, I will move towards the packet side, and then I will make a modification here. Here, the command. In this case, we have the command cmd motor set cmd motor on, which is used to initialize the motor control sequence. Following this, we have the command set motor speed, which is essential for defining the operational speed of the motor. This allows us to control the on-off state of the motor, turning it on and off as needed, while also setting the motor speed to the desired level for various operations. Additionally, we can get the current motor speed, which is crucial for monitoring and adjusting the motor's performance in real time. Let's assume this scenario and organize how the communication works between the control system and the motor. Since we have organized this communication protocol, it is necessary to modify the part of the command that goes to the packet side, specifically the command set motor on, to ensure it is correctly interpreted and executed by the motor control system. This modification is vital for maintaining the accuracy and reliability of the motor's operation. To achieve the desired outcome, you should follow this specific method. Begin by carefully analyzing the task at hand, and then proceed step by step, ensuring that each action is performed with precision and attention to detail. This approach will help you accomplish the task efficiently and effectively. I will try to combine in order to effectively and efficiently achieve the desired outcome without any errors, and in this state, I will modify the code on the side, acting as the sender. Originally, the sender was only able to send in this manner, but for distinction, I will call it TX buffer 256. I will use the memory TX buffer and reorganize the order to link LAN, command, data, CS, and BTX, sending periodically every 3 seconds. Initially, I will assume MX Water 1 off, and then here I will use set enter speed. So, in this case, I will assume that on is represented by 1. To elaborate further, the sender's original capability was limited to a specific method of transmission, which we are now referring to as TX buffer 256 for clarity. By utilizing the memory TX buffer, we can systematically rearrange the sequence to include link, LAN, command, data, CS, and BTX. This reorganization allows for periodic transmissions every 3 seconds, ensuring a consistent and reliable data flow. Initially, the assumption is that MX Water 1 off is the default state. Following this, the set enter speed function will be employed to adjust the speed settings as required. In this scenario, the on state is denoted by the value 1. This approach not only enhances the sender's functionality, but also provides a clear and structured method for data transmission, improving overall system efficiency and reliability. By breaking down the process into these detailed steps, we ensure that each component is correctly configured and that the system operates smoothly without any errors. The use of specific terms like TX buffer 256 and set enter speed helps in maintaining clarity and precision in the instructions, making it easier to understand and implement the modifications. In that situation, since we are turning it off and on, let's first close and then open the buffer packet pose.date. Can you explain why an error did not occur in this situation when I set the command? I was expecting an error, but everything seemed to work fine. What could be the reason behind this unexpected behavior? Set motor on. The size will be approximately 6 bytes in total. Data will be sent to the motor for processing. The ball smoothly rolls into the goal, completing the play with precision after a skillful pass from the midfielder. In this way, we send the command to turn the motor on or off, which can be either 0 or 1. Here, we will send 1. This command is crucial for the operation of the motor, as it determines whether the motor will be active or inactive. After that, we wait for 3 seconds, which is a necessary delay to ensure the system is ready for the next command. Following this delay, we set the motor speed. Let's assume the motor speed is represented by 2 bytes. If we assume the speed to be 900, we will then put the lower byte and the higher byte into the data, effectively sending 900 as the value. This process involves breaking down the number 900 into its constituent bytes, and then transmitting these bytes sequentially. Finally, we send the command for the motor speed, which finalizes the setup and ensures the motor operates at the desired speed. This step is critical as it directly influences the performance and efficiency of the motor. Additionally, it is important to note that the motor speed command must be precise to avoid any potential issues with the motor's performance. Ensuring accuracy in this step is vital for the overall functionality of the system. By following these steps meticulously, we can achieve the desired outcome and ensure the motor operates smoothly and efficiently. I have overwritten it. Following that, obtaining the motor speed is essentially a kind of getter method in this particular instance. So there won't be any data in this case. Here, we are turning the motor on and off using 1 byte of data. Therefore, we put either 1 or 0 in the designated data position accordingly. Now then, for determining and setting up the motor speed, assuming it is represented as being composed of precisely 16 bits and set to exactly 900, the first lower byte will be positioned as being the first one, and subsequently, the next higher byte will go into its respective second position, increasing the digit count overall. I've set it specifically to 7, and another 7. In this specific case, since it acts as a getter method, there is no need to send any additional parameters. And since the data can be left empty, we set it to 5 and create the packet based on the length of the data, using a length of 5. Instead, this is for the pocket. The setter has been prepared like this. To begin with, I prepared the setter in a specific manner and uploaded it to the sender side first. This initial step is crucial as it ensures that the sender has all the necessary configurations in place. Now, let's delve into how the receiver manages and controls the process based on this setup. In this scenario, if the packet is simply verified as valid, it is configured to just list the information. However, we will go a step further here. We will calculate the data rank, which involves assessing the importance and relevance of the data. Additionally, for the command, we will also prepare the data manually for the receiver side. This preparation involves organizing and structuring the data in a way that the receiver can easily process and understand it. Once this is done, we will bring the data in advance to ensure that the receiver has everything it needs to function correctly. This proactive approach helps in minimizing any potential delays or issues that might arise during the data transmission process. By taking these steps, we ensure a smooth and efficient communication flow between the sender and the receiver. After gathering all the collected and processed data, the switch statement. If you use the command to initiate a break, and then, while in the break state, if the motor happens to be on, then obviously the first piece of data that you will receive is going to be influenced by the state of the motor. This is because the motor's activity can affect the data collection process, leading to variations in the initial data received. Therefore, it is crucial to consider the motor's status when interpreting the first piece of data. Oh, that's not all about the creator. The on-off switch is configured to data value 0, and with this setting, you can create something pretty amazing. For instance, for the LED light, I'll just set it to pin number 13. For now, just as an example. It will be set in a way. In this particular scenario, when the specified condition is satisfied, you should proceed to set the ping status to high. This means that if the criteria are met, the system will adjust the ping to a higher state. For instance, if the network latency is within acceptable limits, the ping will be elevated to ensure optimal performance. This adjustment is crucial for maintaining efficient communication and data transfer within the network. To set it up, you would start by configuring the settings in the following manner. First, you need to switch it on, and then off. After that, you should focus on adjusting the speed settings. There is a specific variable dedicated to controlling the speed, which you can modify according to your requirements. This variable allows for precise adjustments, ensuring that the speed is tailored to your needs. Make sure to review all settings thoroughly to confirm they are correctly configured. Since it might overlap with this, it could be confusing. But of course, it doesn't actually overlap. Because I've already separated this with a macro as a conditional statement. So that doesn't matter. But I think I'll just call it speed. Then, to clarify, in this context, as you can see, essentially, in other words, in this particular case. Oh, I made a mistake. When acting as the sender, I should have used roll send to send it, but I need to upload it again. 에러났네요. In this section, I have taken on the role of the sender and have meticulously reorganized the code once more, ensuring that it is properly set to RCB. Additionally, I previously increased the speed, and in this particular scenario, I have made further adjustments to optimize performance. This involved a thorough review and refinement of the existing code structure to enhance its efficiency and reliability. Earlier, in this particular case, the 16-bit data is systematically arranged in such a specific manner that the low byte is placed initially and then followed by the high byte. Here, we also bring in the low byte as it is, and then adjust the position of the high byte prior to adding it, so that it can be properly included in the speed. In order to allow for proper verification, we print a single dot. ln, and here also To achieve the desired outcome, you need to follow these steps carefully. First, make sure to adjust the settings slightly in this manner. Then, proceed to apply the same adjustments here as well. The initial step involves obtaining the motor speed, which is crucial for the process. Ensure that you monitor the speed accurately and make any necessary tweaks to maintain optimal performance. This will help in achieving the best results for your project. Since we need to create a packet here, we don't need to separate it as it will be used together with the TX buffer anyway. This means that the packet and the TX buffer will be combined and utilized as a single entity. We can refer to what we did with the TX buffer and keep it as it is. In other words, the process we followed for the TX buffer can be applied here without any modifications. By doing so, we ensure consistency and avoid unnecessary complications. The packet creation and if you set it up this way, the role of the receiver is now complete. Let's try uploading it to the receiver side now. The gap motor speed has indeed arrived, so the packet should have been sent. But wait, this isn't LN. Let me correct that. It's not LN. I will upload and then send it from the center again. The motor speed has been received, right? The motor speed was set to 900, so it should be set to 900. The packet was sent again with the gap motor speed, and it should have come back with the motor. This is how the communication is taking place. If we look at the code again briefly, what I added today is the TX buffer, which I have included, and then I just extracted the data array here. Next, I set up the speed array for the receiver speed and configured the motor pins with macros. For the receiver, I set up the motor pin separately and intentionally placed the code for setting the digital low in the setup section. Additionally, I made quite a few modifications on the sender side, so it alternates sending every 3 seconds, with the first one being, I have set up the packet to turn the motor on and off, and the second part is related to speed, which corresponds to 16 bits. This is split into 2 bytes for transmission. Next, for the gap motor speed, the center will need to receive and pass the data later. When the gap motor speed is set, the receiver will echo back the speed packet, allowing us to confirm the current speed. The receiver will then differentiate commands using a switch statement, setting the command to turn the motor on, which will control the hardware accordingly. Although I have only mentioned the current speed, in reality, it will apply the speed to the hardware using PWM or any method you prefer. For the gap motor speed, similar to the center, I have set it to send the speed-related information split into 2 bytes. In the previous session, I showed examples of how to communicate based on the packet commands. Please refer to this and modify it according to the hardware or sensors you are using. I will see you next time.